Hello, everyone. Take two here. My name is Ahmed, and I'm on the community team at DBT Labs, and I want to welcome everyone and thank you for joining us at Coalesce 2021, live and unmuted. I'll be your host for today's session, introducing the activity schema, data modeling with a single table, presented by Ahmed El-Samadisi. Ahmed is the CEO of Narrator and has spent his life obsessing over how people and machines make decisions. From building AI algorithms to help block nuclear missiles for Raytheon, to getting WeWork sales org to understand that month-over-month metrics are terrible. He is here to share with you his solution to data modeling and is very well aware that claiming that a single 11-column table to answer any questions sounds like BS. His words, not mine. And more on that ahead. Recently, Ahmed was recognized as one of Forbes 30 Under 30 in the enterprise technology category. In this 30-minute session, Ahmed will present a new data modeling approach called the activity schema. He will cover its structure, how it works in practice, how it makes your warehouse cheaper and much faster, how it really can answer any possible data question. The list goes on. Let's get started. Over to you, Ahmed.
Awesome. Hey, everybody. I'm Ahmed here, and I'm really excited to share with you guys about the activity schema. A single table approach to answer any. Just as Amanda mentioned, before this, I built up WeWork's data team and infrastructure, so there'll be some stories from WeWork. And before that, I worked for Raytheon as a nuclear AI engineer on missiles. So I'm really excited to share the activity schema and how it can answer any question. I really push everyone to start posting the questions that they have answered in the DBT Slack, because I'm going to try to make sure that I touch upon a lot of these questions. And I've had a lot of experience proving that the activity schema can answer questions since I've been doing this for years. So let's make those questions really hard, because I know that this audience is very skeptical and are going to put us to a test. So let's get started. So activity schema really started with this idea of a single source of truth, because every company has gotten in a circle and said, let's build a single source of truth. This has happened many times, and we all love it. And building a single source of truth is actually easy, right? Just make sure that every single piece of data is in one data model and not duplicated across all the data models. Put your BI and visualization tools on top of those single source of truth data models, and you're done. If this approach ever worked, my talk would be done now. But this approach doesn't. And I want to share a story about why it doesn't work, because the reality is really complicated. I remember at WeWork, you probably might know him because he's now a TV star from all the great TV shows and documentaries about WeWork's stories. But Adam once brought me into the office, and he was really frustrated. Marketing was reporting data from sales, and he was having our total sales numbers be a number, and he would show me the report from the sales team, and it had a different number for total sales in February. Which one is correct? And he goes into panic mode. Guys, the numbers are all wrong. Data's all wrong. Everything is all wrong. Everyone here has already experienced a case where one number not matching in one of the thousands of dashboards that we've built, causing a lot of panic in stakeholders to go, everything is wrong. So why does this happen? And why is this question really actually a lot more nuanced than we think? Let's take an example of what it takes to build a single table. I wanted to do a marketing visitors to sales. This is an example that everyone has experienced because this classic e-commerce situation. I want to know every time when somebody visits the site, whether they came from an email, paid or organic, and I want to know from that site visit, did they actually order? Seems very common, and we've all kind of tackled a very similar problem. How do we do this? The first thing we do is we have our web session data, and we have our sales data. Sessions coming from your Snowplow or your Segment, and your sales coming from Salesforce or your Shopify. And you really got to combine it. So we're going to use some UTM parameters. Hopefully the UTM parameters don't duplicate and they're unique and they're maintained. And then we're going to look at our emails, and we're going to bring the emails. How do I attach an email to a web session? Maybe I'll use 30 minutes in activity, 30 minutes of opening email within 30 minutes, and I'll dedupe it using row number so I can start creating this table. I'm sure that we've all kind of created these tables that have joined and done these really fuzzy joins, and you can imagine these SQL queries get really complicated and really messy. And this is just one table. In your warehouse, you're probably doing this thing hundreds of times, and those tables have dependencies and layers of dependencies and layers and layers. So this gets incredibly difficult to manage, and it continues to grow out of proportion. What if we can make it simpler? What if actually the tables that we used and the joins that we used were actually the same? I know this sounds a little weird, but let's go along with me for a second. What if each table that we had looked the same? They just all had the same exact columns and the same exact structure. And instead of these joins being very unique per single question and how we want to combine it, what if all the joins were just based on customer? This would be really easy. You grab sessions, well, know when they happened and who they happened to, bring in the sales if it happened to the same person within the same session, bring in emails if it happened right before it. Then we can recreate this table. This approach is a lot faster and seems to be a lot simpler. Let's take this further. What if we take all these tables, all these little similar tables, and make them into one table? Then we have one table, and we're just self-joining based on customer and time. And then we can create any table we need. So when a new question comes in, we can actually do this again and create another table. When you needed visitors to sales with emails, you take that single table that had your email session and sales data all together, self-join it, and create that table. If you want to add, if the customer called us after the session, you can add that right away. If you want to just do quarterly sales, you can do that right away. It's all just a single layer of dependency. If you've done this before, please tell me the different tables you've created and why you think that a single layer will not actually work. So we call this single table the activity schema. And we call each one of these time-based operators relationships. And together, combining the activity schema and relationships, you can actually create any table you want. Sounds magical, but there's a lot of value in it. So the benefit of the value of this activity schema is that all the data that you care about is in one table. Each one of these activities, and you're going to see it in a second, you can define independently. Because everything is coming from the activity schema, you never really have to worry about numbers not matching, many complex dependencies. Everything is really easy. And because you're really just self-joining to create a table when you need it, you will never need to go back and change the activities. You can kind of define them independently of how you use them. And this creates a really nice world. It creates a single source of truth where actually everything is coming from one table. Numbers will always match. It's super easy to create this table, and it just makes a lot of things faster. It's a single table instead of hundreds. There is a lot of challenges with the SQL that you have to write to use it. We'll dive into that later. This is activity schema. It's a table centered around customer, action, and time. You can take your raw data, bring it into this table, and put all your materializations, your plots, everything you want to do on top of it. So for example, here, your completed order might come from your Shopify data, and your emails might come from SendGrid and MailChimp. And it's super easy. You're just unioning it all together into this single table. And we often get this question, which is, does it have to be a person? It doesn't. We've seen customers do company streams using activity schema for scooters at WeWork. We had a property to see everything that's happening in time. This really resembles how we all, data people and non-data people, talk about what's going on in our business. We talk about our core entity, the person, and they're coming and ordering, they're viewing pages, they're acting, they're behaving, and we can slowly see how those things evolve. Now, writing these transformations is really simple. You have to take the raw data from the sources, bring it into this unique 11 columns, simply map it to those 11 columns, and then you have the activity schema. And if you notice here, these activity commas are always coming from just very simple queries. I know what you're thinking. What about the common identifier? You're telling me you want to get everyone to have a common identifier? You know that page views often don't have emails. They actually have cookies, and tickets might have submitter IDs, and emails might have emails, but all these sorts of it. And we've thought a lot about this problem. You can read a lot about it, but the activity schema and narrator use a really key identity resolution approach, which we can, it's a whole talk of its own, to be honest, but it does multi-user, multi-device, in-time, recursive, consistent identity stitching to create a really unified customer. So for now, just assume that we were able to do it. And if you have any questions, it will be perfect there. So we'll dive into how that customer stitched on the DBT Slack. So feel free to post questions on that. We like these transformations. We like to think about these transformations are very different. It's still SQL, but they're very different kind of SQL. It's super simple. Most of our customers actually write these transformations in 14 minutes, and they average around 25 lines. We're not talking about thousands of lines and dependent on tables and tables and tables and tables. We're talking about very big queries, and all they have to do is define what something is. You often see that the definition is so simple that most people just use that as a dictionary. You want to know exactly what a completed order is? Look at the 20-line SQL query that represents the mapping of the data. And because these things are often simple, there's no complex zoning, you're not really bringing multiple systems, just using this data and combining it into activity schema ends up being really fast. So you're getting this really simple approach and big speed. So hopefully so far we've seen that you write these small tiny snippets, they map into these building blocks, all these building blocks get unioned into this activity schema table. How do we use it? So querying the activity schema is pretty unique. I like to think about it as like fancy pivots or like clever self-joins. So you have this long table and you're going down the long table and you're using that to answer questions. For example, the question we tried to answer earlier, which is want to know everyone who visited the site, did they have an order and what the conversion rate from the site is? If we want to know that by month, it's actually pretty simple. We go down the activity schema and grab every single web visit. For every single web visit, we just look, did that same person complete an order before they visited again? If yes, I'm going to put a 1. If no, I'm going to put a 0. So now we have a table with every visit and whether the person ordered or not. And simply, I can count the number of rows in there to get the total number of web visits. I can sum the total number of did ordered and get the total number of orders. I can just average a did order and get the conversion rate. You're simply going down and it's super easy. The good news is this way of going down the data is what we call relationships. It's a time-based join. Like Jay said in the Slack, everything ends up being 11. So we have actually 11 relationships. So the 11 relationships are really reflecting on the way stakeholders and people talk about what's happening. We've seen these relationships happen naturally. So you're looking at the first time ever a customer visited. Like, I just want to know when they first signed up. You might want to look at when someone's first after or first between, or give me the last time before they ordered, the last time they updated their contract. And I want to know what that value of the contract was. So these little building blocks of these relationships can be used with this activity schema to really generate any table. And I would encourage people to go through and put some questions that they think can be answered, or some tables that they need that cannot be replaced with time-based customer operators. Because we've been doing this for a while, and it turns out you can replace almost all the foreign keys just by using these time-based operators. But let's see how it actually works in real life. Like I want to go through a couple examples to show you how simple questions that as data people we know are complicated can easily be answered in this approach. If you want to do email attribution, so what's the best campaign that gets people to order for every email? So we have every email on the campaign that this email's been part of, and did that email lead to an order? This is a complex question because you can imagine having to deal with clicks and UTMs and and a whole lot of things. But a narrator, using activity schema, it's actually super simple. You just say, give me every open email and give me the first time in between those open email the customer actually completed an order. That's it. You instantly get a table that has every single email with the campaign with the order information right on top of it. Want to know the best paywall to get subscribers? Easy. Grab every person's subscription and see what the last before paywall they viewed. Just by looking at that customer behavior, we can easily understand how these things can generate these tables. And from these tables, then we can aggregate them, analyze them, and do everything we need. Another example is, how long does it take for someone to first come to site to become a lead? Here, we just grab the first time they ever viewed the website and give me the first time after they viewed the website that they submitted a lead. And I can see how long it took to get there, when it did, and how many people actually submitted a lead and the conversion rates. Notice that in all these questions that I was answering, we never thought about, hey, where's that viewed website data come from? Hey, what is submitted lead? These things are building blocks that your business starts learning and using in the language that you speak in. You don't care about data source anymore. This website can come from 7 different data sources. Leads can come from multiple. We've seen actually many customers transition from like HubSpot to Salesforce, and everything they've been doing is still submitted a lead. Doesn't matter that it came from 2 sources, 1 or many different changing sources. It keeps it really simple. And we're constantly speaking about things in time, so we never have to deal with this unique question of how do I tie these 2 things together. This is a nice UI that shows you combining this data. But how does it actually work? Because it turns out when you go to write the query to do this approach, which is why this approach isn't really very common and why a lot of people don't use an activity schema, is because writing these actual queries to do these time-based joins is extremely complicated. You can imagine having to, if you want to do this first in between relationship with SQL, you would have to figure out when the next viewed page happens, then figure out, join in the complete order, then dedupe it and choose the first one. Instead of them, if there's multiple, count them all, deal with what happens if there's no, put a bunch of window functions to make sure that you don't dupe or you choose the right one. And if there's no, you handle it. And it becomes a really messy query. Luckily for you, you don't have to. The whole point of this UI that I was showing earlier is that we can generate those questions for you, those queries for you. You ask the question, you assemble those things using the activities and the relationships, and we will auto-generate a very efficient query that runs on your warehouse that is super optimized and super fast. And when I say fast, it really means fast. Because there's really a lot of, so summarizing kind of everything we've learned so far is that with this activity schema, you can bring all your data into a single table, really representing the way that us humans talk about ask questions and answer them, where every row is a single activity happening to a customer in time. These things are super easy to write and super easy to debug because you just see this customer journey. And you can put everything you want on top of that activity schema. By being able to combine the activities with these time-based operators relationships, you are able to really generate any table. It guarantees the numbers will match because it's the same table. It makes it really easy to add more columns from different activities, like dealing with slow changing dimensions or all these different aspects. You can easily pull in features from other activities, and everything can be broken down to this human readable format that is these building blocks and how they relate. On top of this whole thing, by having this single table, it is a very small table. Like a billion rows there is like 50 gigabytes on your warehouse. So you can scan this table really quickly. You can process the table really quickly. Everything is incremental. There's a whole lot of additional values on your warehouse and time and cost. Like when we used to implement this, they used to be initially implemented as like a time and money saving on warehouses because they're super optimized for these long tables. So not only are you getting that, but you're also getting just a lot faster experience. So then what? Like when this whole thing happens, you get a lot of changes in data and it makes it really exciting. If everyone used the activity schema, you're going to get a lot of benefits because every company is using the exact same table with the exact same structure. You can standardize all of data to give common guarantees and assumptions. And that allows you to share and reuse. For example, like analyses and algorithms on top of the activity schema can be reused for multiple companies because every company has the same guarantees. Integrations, everyone can integrate with the activity schema, which is a standard structure, and really generate anything you need for automatic integrations with any of the common data sources. So you really can create this world where things are shared. Like Salesforce did for sales, you can do this. The activity schema is doing it for data. And I'm sure all the data scientists listening to this talk are excited because we write algorithms are like bane of our existence. There's a lot of assumptions and guarantees that we're getting to make sure that we understand the assumptions and guarantees of the input so that the output behaves. This is what activity schema enables, is this common input, which allows you to really create and reuse analyses. And honestly, we see that daily with our product. Our customers are actually able to generate analyses in minutes by using automatic templates. Because of the activity schema standardized, we're able to actually answer all these complex questions instantly just because of the standard structure. And everyone in the world will soon hopefully be able to do the same thing as more and more people adopt the activity schema. Simpler data modeling, instant analysis is just a better way of doing data. I hope I got to really touch upon what makes the activity schema really special and how it works and all the building blocks. So if you're really interested more into the activity schema and narrator, you can check out our website. You can reach out to me on DBT Slack. I'll be here and I'll dive into these questions. And let's get started with the questions, because a couple of the most common questions that I'm going to try to answer first is, what happens if I have more than attributes? So activity schema is really relatively simple. In querying, if you remember, it really just maps with 3 core features. So this is a very common question to people who have really just haven't used activity schema a lot. You can definitely imagine a world where you, what we call, enrich the activity schema by creating a join on the activity ID and adding as many features as you want, which is the emergency case. But what we see is 95% of our activities used actually don't need more than 3 features, because you can only pull in the features related to that activity. So for example, if you look at any of your tables, you might have like first time they came to site, last UTM parameters, when the person converted, all these different actions. You can just pull them in when you need to using these kind of building blocks, and pull in the first time they signed up easily. Because you can combine all the activities, you can borrow the features from different activities. And it turns out then you actually don't have that many unique features per activity. So we see this always happening where you might want a bunch of dimensions, but it turns out because you can borrow the dimensions from other activities, you're just assembling the table you want instantly and fast. I hope that kind of addressed the question of what happens when you want more than features. And most of the people that actually try it, you end up realizing that often you actually don't even have 3 features, to be honest. It's just because you get so in the habit of kind of keeping these activities simple, you can really just pull in anything as you need. The activity schema is an open source project that you can learn at activityschema.com. In there, we talk about how you write these kind of queries that we see here. So we really introduce the way you query the activity schema and what these relationships are and how they actually conceptually work. The actual tool that we built on top of the open source project is not open, like the UI is is just to make that process faster. So we actually share a lot of our core approach and how you deal with activity, how you create activity schema, how you use it, and how do you query it, all in our open source spec in GitHub. But when it comes to the nice UI, we've built that in to make that process simpler. We find that a lot of our customers that want to use activity schema find that Narrator is just a well-integrated tool to make creating and using activity schema just a lot faster. So the question about identity stitching. So how do we deal with the fact that we get information later? Also part of the activity schema is you're not just inserting data, you're actually doing, after you insert all the new data, you run a couple of updates that processes the data in the past. So there is a whole multi-user, multi-device identity stitching that happens where you can actually go back and update the activity schema to fill in that customer identifier as you learn it later. So there's a lot of those unique features, like we'll talk about that in, I think, on Narrator's doc site. It has a lot of these kind of special case activities that you can use with the activity schema as well, like what happens when someone's fraud, what happens when someone later gets identified. You just simply have these special case activities, and then you can go back and update the activity schema and constantly be stitching that user to create a really reliable global identifier. Because activity schema is just always incremental, and the way it updates, which we talk a lot about in our spec, it is super optimized to now be fast. You're constantly inserting new data, which is only based on the most recent data. You're not really just regenerating the whole thing. And you can constantly stitch that identity and update those set of rows. So that ends up becoming very cheap, very efficient, and it keeps it all within one table. So you're not really just reprocessing everything. You're just working off this one table. Yeah. Customers doing this thing on that. Yeah, we see customers creating DBT building blocks for each transformation and putting them into activity schema. We've seen customers really, I think Fivetran did an open source project to tackle also making the whole entire integration of inserting data using DBT. So there's this really nice, just harmonious world where you can define these building blocks in DBT and combine them to create the activity schema. We haven't been able to actually do the full auto-generated queries in DBT, but as data people learn how it works, you get the habit of how to use it. So we've seen that happen a lot. I identity stitching question, I will put a link in there to help you see how identity stitching works. It is the core part of the activity schema works, because if you're going to build a table that's been around customer and time, you better make sure that your activity schema is as detailed as possible, or your customer is as complete as possible. So it is a lot more nuanced. It's actually one of our more complicated pieces of thinking process. We'll actually add that and try to help really dive these things together. Another thing just to mention, because activity schema is all happening in time and you can use stuff like last before, we see this is really also very helpful for slowly changing dimensions as well, or changing facts. So you can imagine you're a bank and you have like total assets under management for each customer, and you want to know, like, someone opened the app, what was their assets under management? You can just say, give me every time the customer opened the app and give me the last time before they updated their assets under management, and get that exact total revenue. So for these slowly changing dimensions, slowly changing facts that you're pulling them in, because of this time series nature, you can literally not really think about when this happened. You can literally pull in the last time something like that occurred. This really last before for slowly changing dimension is a lot of times why data people really love narrator is just in the activity schema, because these kind of questions take a lot of time to do in SQL and they're really confusing, but you can just define them independently and bring them into the table as you need them. I'm just going through some questions. Yeah. So as we go through more and more of these questions, really just hope everyone gets a chance to try it. I think that getting experience activity schema often changes how people think about data. You start realizing that so much of what we do is so repetitive, and so much of what is exciting about data can be like abstracted away and we can iterate. It's really fun also to see customers that have transitioned from one company to another, that they use the activity schema, where you can go into a new company and see all the data in the structure of the data being the same from one company to another, and you can instantly pick it up. You just gotta learn what activities mean, and it makes asking and answering questions. It makes answering a question with data just as easy as asking it. And that's the beauty. Like, we tell our customers, if it takes you more than 15 minutes to answer a question with narrator, you're probably doing something wrong. Everything should be that simple, because activity schema is a way of thinking. We put all these constraints in place so that the only thing you're thinking about is, how do I think about the customer journey and what am I looking for? And then I can easily assemble it. And the more people that do that, the faster we're all able to answer questions, the more we can make correct decisions. And I think the better world. If anyone has any more questions, feel free to post it. But like, the proof is in the pudding. I have been saying this thing forever. I think that if you're ever skeptical of activity schema, please try it. And let's just see in action, because if you can find questions that we can't answer with the activity schema, like proving by contradiction, then great. But in the last 5 years, we haven't really seen any question that the activity schema cannot answer. And I'm excited to have you guys all experience that today.